How do we know what kind of asymptote we have? We're going to go after something called an end behavior model. That tells us the type. It doesn't tell us what it is necessarily, but it tells us the type that we have. So remember that we said a rational function is a polynomial divided by a polynomial. This is the general definition of a polynomial. It would be a sub n x to the n plus a sub n minus 1 x to the n minus 1 in descending powers, all the way down to the constant. And then I would be divided by a second polynomial, starting with the highest power all the way down to the constant. If I take a look at what's in control, so I'm going to look for a controller. What's in control really is the highest powers. Because we want to find out what happens as x gets large. That's what end behavior is. For us, it would be x goes to positive infinity or x goes to negative infinity, plus or minus infinity. And the bigger x is, the lesser of a role any of these other terms play. So who's going to be in control is this guy. And this should be, this should be m rather than n. It should be the quotient of the highest powers, or we know this as the quotient of the power functions. Because this guy, he controls everything in the end. For large x, everybody else falls away. Now what this does is, this begins to tell me what type of asymptote I have. So if I look at what the end behavior model is, I call it EBM for end behavior model, it's the quotient of the highest powers. Because as x gets very, very large, 2 is not going to have a significant impact anymore. It's going to be 4x over 3x squared. And if you reduce this down, this is going to be 4 over 3x. That's what the model is. And long term, what I then do is I look at finding what type I have and what it is using the model. If you remember any constant over x, as x goes to infinity, where does this guy go? As x gets very, very large, any constant over x goes where? 1 over 1 million, 1 over 2 million, 1 over a trillion. What number does it become? 1 over a very, very large number, you can't tell the difference between it and what? Infinity? One divided by that says 10 times, or 1 times 10 to the negative 6. 1 times 10 to the negative 6 says it's 0.1, 2, 3, 4, 5, 1. What number is that close to? 0. Now, if x were in the numerator, that's when you're looking at infinity. When x is in the denominator, what we're looking at is 1 over infinity, for all intents and purposes, is 0. Anything over infinity is 0, because it's a huge number. So that says, as x goes to infinity, 4 over 3x goes to, essentially, 4 over 3 times infinity, which is 4 over infinity, and 4 over infinity is 0. This says I have an HA. Here, the end behavior model, there's your quotient of the highest powers. And what happens, I'll get my pens up here right now. So as what happens, as x gets very, very large, 2x compared to x squared is very small. It doesn't add anything to it. 9 adds nothing to it. It's kind of like you're looking at a billionaire and trying to give him $1. How much wealth does that add? For a billionaire, nothing. Even if you would try to give a billionaire $1 million, how much wealth does that really add? Not much. To us, it's a lot of money. But if you're looking at somebody who has billions and billions of dollars, like Bill Gates is sitting at, I don't know, he was at 39 billion at one point in time. $1 million is nothing. Absolutely nothing. It's like $1 to us. Well, sometimes $1 to us is pretty significant. Depends upon how close the payday it is. So, or the end of the month, depending on one of the two things. So, but at which point in time it says anything smaller than when I'm looking at x getting very, very large, anything smaller in power, in degree, than the power function drops away. So the end behavior model is 4x squared over 3x squared. The x squareds drop out, which is 4/3. This is a constant. And as a constant, does he have any x's? No. So that says x goes to infinity, he says big whoop. Because he can't go with x. Why can't he go with x? He can't go with x because of the fact that he has no x beside him. He's constant. He will never change. X can go any place he wants to go, but it's not going to matter to him because x is not going to take him along. He doesn't have an x. So a constant means degree 0, and degree 0 means I have an HA. Here, the end behavior model is that guy. It's the quotient of the highest powers. You can always depend upon, essentially, you can't depend upon that it's going to be the leading term. You have to make sure you make a quotient of the highest powers. Now, if I reduce this down, this is 4x over 3. We know it as 4/3 x. This is degree 1. That means what I have here is an oblique asymptote. And he's going to be more work to find. An oblique asymptote whose family name is 4/3 x. I don't know what his y-intercept is, but he is certainly the first term of that asymptote is 4/3 x. And then we have to work to find the rest of it. The end behavior model tells you what type you have. And this reviews what we just did. It says, if I had 4x squared over 3x squared, the model reduced is 4/3. Since it's a constant means we have an HA. And because it's a number, the HA is y equal 4/3, and it is degree 0. When we had 4x squared divided by 3x, the model was 4x over 3, or 4/3 x in reduced form. It is degree 1. And since it is a linear expression, we have an OA, and the OA is 4/3 x, but we don't know what the y-intercept is yet. It could be 0, could be something else. But we do know that it's 4/3 x plus something, or minus something. If we have x left in the denominator, we have to look at this guy now. What happens as x goes to infinity? Well, we said as x goes to infinity, this is essentially saying this. X becomes infinity, which is 4 over infinity, because 3 times infinity is still infinity. And that means this guy is going to 0. This is a constant. And so we have an HA. And the HA is y equals 0. Degree 0 of my model is an HA, and y is going to be equal to the model. If I have an x left and it's in the denominator, it's going to go to 0 as x goes to infinity. It's y equals 0. And it's an HA. If I get my model, and my model is degree 1, I have an OA, oblique. We just have to find out how to get it.